Well, all right, here we go, starting the last chapter of first semester, chapter 7, applications of trig. So looking at how we can use these trig functions with more than just evaluating them. So the first lesson today, and we're looking at the law of sines. So we're going to be using the sine function to work with some triangles and solve all the missing sides and all the missing angles of a triangle, specifically oblique triangles. So an oblique triangle just means that it is a non-right triangle, so an acute or an obtuse triangle. And we're going to be kind of channeling some of our geometry student knowledge. One of the first things in geometry was how important our diagrams are. It's going to be the same thing in this chapter. So just a quick reminder, when you're drawing your triangle, we label our angles with capital letters, and then the sides opposite the angles will have the same name just with a lowercase letter. So if this is angle A, the side opposite it is side A. If this is angle B, the side opposite is side B, and so on. Okay, really important that you guys label your triangles carefully like this because you have to match up the angle and its opposite side. So the law of sine is this proportion here, that the side A divided by the sine of angle A is equal to B divided by sine of angle B is equal to C divided by the sine of angle C. Obviously, we're going to only use two ratios at a time so that we can actually cross multiply to solve. The reciprocals of this proportion works as well, so you can set it up that way if you prefer. Just remember, side and angle correspondence here should be in the same ratio. Okay, so the law of sines can be applied in a variety of ways. Today what we're going to look at is applying this law of sines when the information that we're given is in the form angle, angle, side, or angle, side, angle. Okay, so if you remember in geometry, we used these with proving triangles are congruent. We're not going to do that here. Instead, this just refers to the order in which the information is given to us and how it's laid out in the triangle. So if you're given two angles and then a side length, then you can use the law of sines. If you're given two angles and the included side, then you can use law of sines. And that's what we're going to see today. Okay, we'll go through all the other examples, scenarios later this week. The other formula we're going to need for this lesson is the triangle area formula. So we know from geometry 1/2 base times height, where base and height are perpendicular, right? But since we're looking at oblique triangles where we don't know the height, which is the perpendicular segment to the base, we can use a different formula which utilizes the sine function. So 1/2 A times B times the sine of C. This time we can use this formula when our triangle information is given to us in the order side, angle, side. So again, a little bit different from what we saw over here. So we have two sides and this time the included angle. So if you're given information about a triangle with the two sides and the included angle, you can use these formulas. Now these three formulas are exactly the same. It just depends on which angle is the included angle. So it's the two sides, then the included angle. Okay, so let's just go ahead and jump into an example and we'll see how this works. So example 1 says solve triangle ABC if it has these characteristics. So we can draw our triangle. It's an oblique triangle, so not a right triangle. It doesn't really matter what it looks like. And you can label the angles however you prefer in any order, just as long as when you input the information, you're putting them all in the right spots. So this tells us that angle A is 32 degrees, angle B is 81.8 degrees, and then it tells us that side A, so that means the side opposite angle A, is 42.9 centimeters. So as you can see, we are given information. We have an angle, and then a side. So because this is angle, angle, side, we can use law of sines here to solve for the missing sides and the missing angles. So if we're given a triangle and we know 2 out of the 3 angles, we can use our prior knowledge to solve for the missing one. We can just do 180 minus the angles that were given to us. to solve for the missing one. So we can say the measure of angle C is 74.07 degrees. So I'm going to go ahead and put that in here in case we need it later. Oops, I'm sorry. That's the wrong answer. I'm looking at the wrong number here. Angle C is 66.2 degrees. That makes more sense. 66.2. So we solved for all of the missing angles. Now we have to solve for all of the missing sides. So with the sides, because we have angle, side, that was the original information, we can use the law of sines to solve for the missing sides. So the missing sides are side B and side C. So just like we saw up here with the law of sines, we don't have to set up all three. We only need to set up two at a time. So since we know side A, I'm going to start with this one. So 42.9 divided by the sine of angle A, which is 32 degrees. So I'm going to start with that one, and then I'm going to use that to solve for one of my missing ones. So I'll solve for side B next. So side B, we don't know, but we do know this angle B is 81.8. So I can set up my proportion, then cross multiply. You guys can press pause and do that on your own and check to make sure that side B, you get 80.13 centimeters. Okay, now we can do the same thing to solve for side C now. So again, I'm going to use the same given information with A divided by the sine of angle A. Since we were given A and A, I'm going to always start with that ratio, and then I'm going to set that equal to side C divided by the sine of angle C. And remember, we had to solve for angle C on our own. Wasn't too difficult to do, but we did have to do that on our own. When we cross multiply, this is where that 74.07 came from before. That's the side length for angle C. Okay, notice how my work is organized and labeled. I have my equation that I used written out, and then the answer labeled and all that good stuff. So make sure you guys are doing the same thing. But that's how we're going to use the law of sine to help us solve for missing parts of a triangle. So here's one that's an application here. How can we use all this stuff to find useful information like this one, Sheldon Cooper, which is to measure the distance across a river, right? We can't actually take like a tape measure and measure across. How do we figure out how wide the river is? Well, instead we can find some angle measurements from different points along the river, and then we can use the law of sines to solve. So they ultimately want us to find the distance, which is A, across the river. So this is what we're solving for, A. Notice they give us angle A. So here, as far as our ratio goes, we kind of already have that first step. So as far as the sides go, we know that side A, which is what we're looking for, over the sine of angle A, 31.1, we already have. Since we have an unknown here, the other ratio should be values that we definitely know. So I'm going to need another side length. Well, do I know side C? No, we know nothing about that, but we do know we were given side B. So side B is 347.6 feet, and that should be divided by the sine of angle B. So angle B was not given to us. However, if we know angle A and angle C, can we solve for angle B? Of course we can. To solve for the missing angle, we would do 180 minus the 31.1 minus the 112.9, and we'll get that the measure of angle B is 36 degrees. So we weren't given angle B, but we could solve for it pretty easily, and we can plug that into our proportion, and now we only have one missing value, so we can cross multiply to solve. And A, the distance across the river, is 305.46 feet. So again, we can use the law of sines to find missing parts of a triangle. Just to remind you guys about the given information here, we were given an angle, and then the included sign. So this was angle, angle side angle, which was again one of the ways we can use law of sine. All right, let's keep going. So this one, they give us a diagram. Speaking of all those, we have side, we have side, angle, side, right? The information that's given to us is in the form side, angle, side. And like we had discussed before, when we're using and trying to find the area of a triangle, we need to make sure that the information is in this order, side, angle, side. So we are allowed to use the area formula, which is going to be the product of the two sides. So here's A and C. So 1/2 A times C times the sine of the included angle, which in this case is angle B. So we use that formula and then we just plug in. Side A is 34, side C is 42, and angle B is 55 degrees. So we plug that all in, multiply across, and the area of this triangle is 584.88 square feet. Remember, when you're finding area, your units should be squared. Okay? Awesome. And the last example here, another area formula. So we are keeping that in the back of our mind, but we need to confirm that we have side, angle, side information in order to solve. So again, I'm going to draw my triangle to get a visual. They're telling us that the angle A is 24.67. Angle C is 52.67. And then side B, so the side opposite angle B, is 27.3 centimeters. Now remember, in order to use the area formula, the information needs to be side, angle, side. Is that what they gave us here? Unfortunately not. They gave us angle, side, angle. So in order to solve for the area, so we need side, angle, side in order to use the area formula, which 1/2 A times B times the sine of angle C. So since we need side, angle, side, what we need to do, we need to solve for either, we have options here. We could do side, angle, side and make angle A the included angle, which means we need to solve for this side, or side, angle, side, where C is the included angle. It doesn't matter. For me, I'm going to solve for A. So we need to solve for A so that we can use the area formula, and we're going to solve for A using the law of sine, basically what we've been doing this whole time. So we have what we know. We know that side B is 27.3, which means we're going to need angle B. Well, they didn't give us angle B, but we've already discussed that we can solve for this one. Angle B is 180 minus 52.67 minus 24.67. So really quickly, we can find that the measure of angle B is 102.66 degrees. And we're going to use that to now solve for the missing side. So side B, what we know, divided by sine of angle B, 102.66, is equal to, now this is what we're solving for, we need A, divided by the sine of angle A, 24.67. So we can cross multiply and we get that A comes out to be 11.68. By solving for A, now I can re-highlight here. Now I have side, angle, side, which allows me to use my area formula. So now I'm going to come over here and say, all right, well, the area of this triangle is 1/2 the product of the two sides times the sine of the angle. So the two sides we're going to use are 27.3 and 11.68. So 27.3 times 11.68, and the angle that's included, the angle C, is 52.67. 2.67 degrees. So we can multiply across and get that the area of the triangle is 126.77 square centimeters. So this one was a two-step problem. We needed to use the law of sines before we could use the area formula. Awesome. Well, I hope this makes sense. Make sure you guys come to class with your questions. Have a great day.